You are listening to the IoT For All Media Network.
Hello, everyone, and welcome to another episode of the IoT For All Podcast, the number one destination, resource, publication for the Internet of Things. I'm your host, Ryan Chacon, and on today's episode, we have Erik Fossum, the founder of Disruptive Technologies. Super fascinating company. This is a great conversation. For those of you who may be unfamiliar with Disruptive Technologies, they build the world's smallest wireless sensor and sensors for commercial real estate. It's actually very fascinating, the stuff that they have and the tech that they've developed. So definitely go check them out after you listen to this. In this conversation, we talk about the future of IoT and its use within corporate-owned real estate. We talk about the pandemic and how that's kind of influenced this market, general challenges associated with this industry, and where the world is kind of going when it comes to measurements, data collection, and kind of the phases that we've gone through, everything from the computer phase to the internet to the cloud into now the physical world, with this data that IoT is kind of enabling us to now gather off these physical devices or physical things, I should say. So a ton of great value here from Erik, and I think you'll get a lot of value out of listening to this. So hope you enjoy this episode. But before we get into it, if any of you out there are looking to enter the fast-growing and profitable IoT market, but don't know where to start, check out our sponsor, Leverage. Leverage's IoT solutions development platform provides everything you need to create turnkey IoT products that you can white label and resell under your own brand. To learn more, go to iotchangeseverything.com. That's iotchangeseverything.com. And without further ado, please enjoy this episode of the IoT For All Podcast. Welcome, Erik, to the IoT For All Podcast. Thanks for being here this week.
Thanks, Ryan. Nice to be here.
It's great to have you. Let's kick this off by having you give a quick introduction about yourself to our audience.
Yeah, thanks. My name is Erik Fossum, and I'm the founder of Disruptive Technologies. We're providing the world with the smallest IoT sensor there is, with 15 years of battery lifetime, and the full IoT solution behind, so that basically there's data available on an API.
Fantastic. One of my favorite things is when we have founders on the show. So we get to ask them about the story behind the company, the kind of the founding story, what opportunity you saw in the market, and kind of what was going through your mind when the company was started and grow and having it grow to where it is now. So I'd love to hear a little bit more about that if you could share.
Definitely. My background is from physics and semiconductor design. So joined a company that did the world's first digital radio transceiver in CMOS technology. That company was acquired by Texas Instruments in 2005. And another company was started by the former CEO named Energy Micro, where we made the lowest power microcontroller in the world, also the first 32-bit microcontroller. And with the radio part of this, that was basically one of the chipsets that made the world wireless, with keyless entry for cars, Sony PlayStation, home and alarm systems, and so on. And this microcontroller saves a lot of battery in battery-operated applications. Although we don't feel like that today, hopefully with this chip, the battery has been extended on the devices around us. What we saw was that these chips was often used in sensors, and building easy and reliable sensors and be able to use the data from those sensors in applications were very challenging. So there was a lot of consulting involved on our customer side. And so the kind of idea was to make it, instead of hard to get data from the real world, make it extremely simple to basically solve everything that was needed to get data from the real world and into a Google document or into a software application. That would mean that we would have to make certain choices of the technology, and also where it was needed to do a lot ourselves, because a lot of the technology needed didn't exist.
Gotcha. Yeah, and so what's it been like since the company was founded up until now? Like, where have been just internally, like, what you don't mind sharing is, where have been the biggest like roadblocks and challenges that maybe you didn't foresee when you started versus that you had to overcome and helped you be successful?
Oh, thanks for the question. There's been a lot. The sort of spearhead application that we started with was temperature measurement.
Okay.
Because we wanted to make a small sensor so that you could fit into all sort of applications. And instead of having a cable to a sensor, you would basically just have radio communication, and the sensor is as small as a postage stamp, so you can basically place it everywhere. And then in a fridge or in a freezer or on a motor or wherever, and get those data from those devices. And we specify the product to be able to operate from -40 to +85 degrees, so that you didn't need to sort of pick a specific sensor for all sort of applications. But it turned out that in order to deliver on this, we would need to build our own semiconductor, because the sensor would be small. We need to spend like 100th of the energy consumption that a normal sensor does. So we're running at tens of nanoamps instead of tens of milliamps or microamps. And then we had to make our own radio protocol, our own cloud system, operate the subscription services, build our own manufacturing line, buy the machines, the processes in order to manufacture it was established. So it was a massive project for us. But still, the value of this is that we are able to have a one-stop solution to get data from the real world. And I have a lot of examples, but building hardware is really hard. And when you build new hardware, it's exceptionally hard. So just for example, the blister that we have on the outside of our sensor, the sort of plastic material there, in order to source that, we found a company in Italy, and they didn't want to sell us, and they said, okay, but if because we're only selling to medical companies, and that's what we do, and you're in the electronics business, so they didn't want to sell us, and also the minimum order quantity is 2 tons, and I said, we don't care, we need this material because that's well specified, and it's what we want to what we have found to be the right material. And obviously we just need like 0.1 grams or something of this material, but still we bought 2 tons, and we had it on a trailer up through Europe. Wasn't able to cut it in Europe, so we shipped it to UK, where the material was cut, and then the blistering forming machine was in Scotland, so we had to ship it up there. But that machine was a beast, so we couldn't buy that. So we found another machine in Denmark where we actually could do this prototyping ourselves. And then that machine we bought, but the manufacturing line is in Germany. So then we moved it over there. So there's a lot of these kind of examples in order to build the manufacturing part of it, which is exceptionally hard. I mean, manufacturing and production in scale is just insanely complex.
I bet, yeah.
Because there's a lot of investments, administration, and the iteration cycles because of this, and logistics it takes time, and there's a lot of different field matter experts needs to be involved as well.
Yeah, that makes total sense. Yeah, I know hardware is very difficult. There's a lot of pieces that are a challenge at times, especially when you're trying to innovate on something so unique that has such potential for the space with what you all have going on. Can you talk a little bit about kind of the application of your sensors and kind of where they are most widely used, or any use cases you're comfortable sharing, just to kind of give the audience a more complete vision of how the devices you've created are being used and being interacted with in the real world?
Yeah, definitely. So what's happened over the last years is that these cloud applications that have sort of been busy building themselves and been fantastic tools to make operations of service companies, for example, much more efficient, because they have these great tools that they also can use on iPads, and start to use these iPads and devices out in the field more and more, and find them reliable. What's happened is that I've always been talking about that this is what is going to happen. This is our vision. This is what is going to happen. Now that has happened, and it's also a lot of interest around getting automatic data from the field and into this application. applications. It could be as simple as optimizing cleaning routines, for example, counting how many times a door has been opened and closed,
Right.
and then clean, say, just every 50 times that door was opened and closed.
Gotcha.
And it's demand-based cleaning instead of like frequency-based, which is just completely different world, both when it comes to cost or efficiency and when it comes to quality. If the room is often used, then you clean it more often, and less you save cost. So we see a lot of these type of applications. Then it's that sort of connects with that whole space of room occupancy to detect if people are in the room. Our sensors can be placed under a desk, and then basically you can detect if there is a person on the desk or not by the temperature radiated from the body, and very reliable. Also, we have detectors that you can put in the ceiling to detect if there's people in the room, and obviously in the real estate, commercial real estate space, there's a lot of different use cases around that. We also have air quality sensors and relative humidity and ambient temperature, which is the biggest too hot, too cold sort of complaint issue out there for facility management. So that's kind of a big part of it. And we also have like property damage protection, which is water leakage, for example. You can place a sensor at the drain and see if and get a warning if there's water there. You basically just get that single data point. Is it water or is it not at that point? And then a lot of, related use cases to this.
Sure.
Some concrete use cases that we're doing with partners, because we are basically a telco to provide data for these software applications. So say, for example, that you want to optimize your building operations, reduce energy consumption, and you want to make a more healthy and productive space. That's kind of the goal from any of these applications that are focusing on delivering a product. One with Envio, where they are building an end-to-end solution to digitally connect and monitor and control commercial buildings, and it's actually incredibly efficient if you start to get the correct data and are able to do corrections and optimization based on that. They have a use case published with more than 30% in monthly electricity, almost 50% in manual labor costs, and minus 30% on CO2 emissions. And it's kind of amazing what data can do with analytics on top. When this is sort of placed into the operational routines of the service companies. And then also we also see that like more to the more exotic use cases, as in the Royal Opera House, there is golden leaves in the ceiling, which is very sensitive to heat and to humidity. But measuring temperature at this ceiling level is tricky. And also it depends on a lot of environmental factors. So what they are doing there is they have, I think, 250 sensors in that environment, and then making sure that the temperature and humidity is at the right level, and it can take proactive actions instead of needing to do this manually, and that you're outside these boundaries that are defined.
Something you mentioned, you're talking about the data and kind of the ability kind of for us to collect it in a lot of different situations here. And I'd be curious just to get your opinion on kind of the evolution of that. And what I mean by that is, we've come a long way in our ability to collect data, where we collect it from, how we collect it, what we do with it, and so forth. From your experience, where have you kind of seen I guess, where are we going in a sense of how we measure and collect data from, the computer age to the internet to now? What does that kind of look like in your mind, and how do you kind of think about that?
Yeah, thanks again for the question. It's very interesting. I think what sort of have happened is that in the 80s we have the PCs, disk drives, and keyboards.
Sure.
Then the internet came, and we sort of had access to the world of written information, or on the web, and were able, obviously, to send email. So these devices were connected, and what happened along this line was that we got cloud solutions, and they, in the beginning, they were, as mentioned, busy building themselves, but all the data entered there was by hand, or, to be honestly, by two thumbs out in the field when the iPhone came, and
Right.
and then this moved to try to integrate more of the data outside, and we sort of had this wave of API and connections between different cloud services. The next step now is to integrate with basically the physical world. The problem in the physical world is that this data doesn't sort of exist digitally. It just doesn't exist. In larger commercial real estate, there is BMS systems, building management systems, that are basically computers that collect data from the building and are able to control the building as optimal as possible. And integration with these systems have happened. But the problem with this BMS system is that most of them were built 10 years ago, 20 years ago, 30 years ago. And they only have sort of some specific data. And now they request to have CO2 information, occupancy data, more sort of environmental data that needs to be added. So that's where we come in and basically fill out the gaps in data.
Gotcha. And one of the I was thinking about this when you were talking earlier about the use cases. And you talked a bit about the corporate-owned real estate market, which is a market we don't talk too much about. We talk about smart buildings and things like that, but not specifically the market you're mentioning. And I wanted to get a sense of how you see the use cases potentially evolving in that space, the future of that space, just kind of like high level, how the Internet of Things is really influencing that space. And the reason I ask is because, we just went through the pandemic. We're kind of coming out of it now. And I know there were a lot of companies who have shifted their focus from where to kind of devote their resources to. And a lot have pushed it towards the IoT side in buildings and healthcare, a number of other spaces, to have those use cases rise to the top because of the pandemic. And I'm curious, from your point of view, where you kind of see the future of IoT in that corporate owned real estate market, and then at the same time, have you kind of seen a shift anywhere due to the pandemic as far as demand for certain use cases?
Concrete answer to if we're seeing a shift, definitely. It's kind of before the pandemic, a lot of what we were talking about was kind of more on the visionary level.
Right.
Then I think it definitely has accelerated the digital transformation. You see that obviously with just video meetings. It's all over now, and they start on time, and everyone seems to adapt to that way of communicating. And what that has also done to many businesses is that they sort of trust more digital solutions. They trust more that clouds are stable. They trust the internet. And so for us that are delivering data over the internet, that's what we do. We don't have any other option.
Right.
They start to trust that this is how it works. So I think there's basically two things that I would like to underline when it comes to maybe focus on commercial real estate and corporate real estate. And that is, especially on the corporate side, those that own buildings themselves, like the big Fortune 500 companies and so on. Workplace health and well-being is something that they put more effort into. That they want to make sure that the employees thrive and are safe when they come back to work, and also want to show it. To be honest, they want to really make sure that people are happy at work and that things are safe. And so there's investments going in there. And the other part that we see as well is the energy efficiency and sustainability part of this. Very often you can save cost, and that transfers also to sustainability, because you basically becomes more efficient,
Right.
And then it's also more sustainable. And you might not use that much energy if it's the temperature adjustment or HVAC adjustment. But this is kind of where we have seen a big change. And I think just the digitalization in general has changed. When it comes to more commercial real estate, the re-renting, it's more about, I would say, the dark rooms and how you operate the buildings, because that's their responsibility. They have the infrastructure and they contract that. So, for example, instrumenting, motors, HVAC, the leakage part of this. That's more a focus there. But I would say on the top of the outline, I would say that IoT in the future, not only IoT, but like this massive digital infrastructure of internet and the IoT, it's all to increase efficiency and increase quality of operations and extend lifetime of assets. And all of that makes sense when it comes to sustainability as well. And obviously they would not maybe need that many man hours on those activities that are measured, because that's part of what you, but also there will be many other opportunities around this space to deliver services that doesn't exist today.
And where do you kind of see this going, just like into the future? We're talking about sustainability. I mean, obviously what you all have going on is incredibly innovative and has tons of potential use cases that just probably, not that you're already involved in, but I'm sure haven't even been thought of yet. When you go long battery life, small form factor kind of thing, what does the future kind of look like in your mind, as far as you can take it from just, the IoT in general, or more directly related to the hardware side? Totally up to you, but I'm just curious to get your thoughts.
I think the efficiency part, the quality part, and the extending life of assets is sort of the goal for the capitalism, and also is what businesses are sort of striving to achieve. So and in order to be able to deliver on that, you would like to understand what's going on, and you do that with measurements. And so the world will be more and more measurement driven. Today there's a lot of I would say guesswork out there, but it will be more and more fact-based. There will be more and more algorithms behind making the decisions. People would need to be involved in the beginning to train those systems, to make sure that they do what they should do, and they do that in the right manner. But then this will be more and more work orders will be triggered by machines, and humans would execute on those work orders in the beginning. But then also there will be automation loops on those work orders. For example, adjustment on an HVAC, that will be with a connection to the BMS system, which will then correct that loop automatically without people involved. And then later we will robotics as well, of course. But there's some time to that. But we're sort of in a broader space. We're entering an autonomous world where sensors and in a broader term, like cameras and all input devices, are basically collecting information. Then we have an analytics layer that are doing the interpretation of these data, and then we have a feedback and control loop with an actionable layer as well that actually does this. And the goal here is to observe through the input system and then correct it with the actions, and then the world will run more and more autonomously, and that's the most efficient, the highest quality operations, and the longest asset lifetime you could potentially have.
Definitely. Yeah. On the other side of the kind of this conversation we're having, I know earlier I asked you about some of the challenges that companies face, things you've kind of overcome. But as you look at the industry and kind of that space as a whole, where do you see the biggest challenges currently lie, and how do we kind of get past them?
Yeah, I think there's a lot of challenges, and we do not solve them all. We certainly have our challenges ourselves. I mean,
Sure.
one of the biggest challenges for us is that we, when it comes to go to market, we sort of need to be part of building the and work with our partners and the service companies to change in order to use data in this way, because it isn't there yet for all of them. For some of them it is, and they're operating more and more efficiently. But it's just started. But it started with an incredible speed over the last half year compared to how it was earlier. And then I think please repeat the question. Sorry there, Ryan.
Yeah, just more so along the lines of the challenges that you're seeing in the space, as well as how we can overcome them. And it can be industry kind of use case specific if you like, or it could be more just kind of as a whole, kind of what we're running into.
The
Yeah.
IoT space and the go-to-market and all of this
Right.
is moving. Like the companies and their position need to find its place in the ecosystem. And then when it comes to the technology, there is a lot of challenges in general, and it depends on the specific use case. We're not solving everything, but our sensors are good where you need many sensors at the sort of same place, where you can you want to have sensors that are placed on objects, so you don't need to
Right.
cable them, and it's extremely simple to commission and to pair and all of these things. So it's basically you can install 100 sensors an hour without any pairing or anything. But for like an industrial machine, you might need to other type of sensors, which are basically installed on that asset. So I think today there's a lot of fragmented solutions or fragmented type of sensors. Friction is still an issue. For many of the simple use cases, we could be an answer, but it's still 10 years or 20 years where there will be tremendous opportunities for our partners and hopefully for us as well.
Absolutely. No, it's very, very exciting. Things going on. I mean, there's going to constantly be challenges that we have to overcome, figure out ways around. And I think just the challenges have kind of shifted. But as those new challenges have come, it's usually because we've solved the old ones. So it's a very exciting time, I think, with IoT. Yeah.
And so the sort of next level of friction is entering because we have solved all problems. And a problem that is also very apparent now is sort of all the APIs and the sort of cumbersome way of integrating all of these APIs and get them to understand each other and so on. So there might be some good ideas on that out there, which will accelerate this and other companies in the future. Just on our previous discussion, Ryan, with sound sources as well, is kind of Apple make it extremely simple to get sound from all sort of devices around us.
Right.
The problem that emerges is that it's too simple. So suddenly the sound comes in from the car and your kids, and then your headphones is suddenly starting to work with a microphone, and so there's all these friction points that sort of because we have taken the world a step forward, we also meet the next barrier.
Definitely. Yeah, it's we simplify things to the point where, we solve problems, and then we got to figure out, well, now how do we solve the problems at that simplicity cost? So
Exactly.
it's super interesting.
Also, the interesting thing is that I think if someone had seen how we're living now
Yep.
100 years ago, um, I mean, obviously there would be much to learn, but at the same time, it's a very, very, very frictionless world. I mean,
Oh yeah.
we've been we are very, very sensitive to friction on all the devices around us because it's been so well optimized.
Yeah.
And so all of these bits and pieces that then suddenly pops up of the noise floor, which is with friction that we have to solve, they're not that severe, but still we feel that they are challenging.
But there's also, there's companies, and most companies, even in that regard, they are founded on the premise of solving some kind of friction that they experience in their industry and their space. And then as they solve them, new friction emerges, and either they or other companies jump in to solve those pieces of parts of friction. So,
exactly. But I think,
yeah,
honestly, this is the reason why this is now sort of this friction space, and we feel that this is evolving, but still that there's always challenges, is that the internet has emerged, the cloud services and cloud systems on top of that is the infrastructure is so available and easy to deploy at scale. So there's sort of the hard thing now with applications is to build good reliable applications, but the infrastructure is all there.
right.
And then that iteration loop across companies across the world is going much faster.
Definitely.
But if you look like 100 years back, I think they sort of had some of the same problems, but just in other feed matters, like, for example, electricity. When electricity came 130 years ago, then there were a lot of discussions, a lot of innovation, because this sort of massive type of infrastructure was emerging. And then it stabilizes. Now it's almost no innovation relatively on sort of new applications with electricity. But for 100 years ago it was.
Sure.
But now the same thing is happening on the internet with all of these applications that over the next 100 years will sort of compete, and new problems will emerge that will be solved, and next problem and so on before it's stabilized.
Yep. Definitely. Absolutely agree. Well, this has been a fantastic conversation, Erik. Thanks so much for taking the time. I wanted to ask you, as we wrap up here, for our audience out there listening, what's the best way for them to kind of follow up with questions, stay in touch, kind of just stay in the know of everything going on your end, and if there's any new and exciting news coming out that we should be on the lookout for?
Yeah, our webpage is always updated, and also if there is specific requests or anything, I'm happy to answer that myself as well. So Erik with a K at Disruptive Technologies. I'm happy to forward that to the relevant persons.
Fantastic. Well, Erik, thanks again for your time. This has been a great conversation. We're going to be doing a bunch of new content coming out in the coming weeks and months. So I'd love to have you back, have other members of your team involved, just to kind of talk more about some hardware areas, because that's one series I want to start is around hardware specific conversations. And I think you guys have a ton of knowledge to share there. So that'd be awesome to do. And then the other one is around solutions and stuff. Yeah. So we'll have you back. Thanks again so much for your time, and look forward to talking again soon.
Same to you. Thank you. Right. Bye-bye.
All right, everyone. Thanks again for watching that episode of the IoT For All podcast. If you enjoyed the episode, please click the thumbs up button, subscribe to our channel, and be sure to hit the bell notification so you get the latest episodes as soon as they become available. Other than that, thanks again for watching, and we'll see you next time.